In this unit, we're going to talk about DHCP and DNS, and we've talked about these topics before in the follow-on course to this course, Server 1. But we're going to touch on this again and talk about some of the advanced options available to us in Windows 2012 Server, and also they're available in 2016 as well. So we're going to do we're going to cover the following objectives: describing DHCP components and operations, just a quick overview of DHCP. This should be a review from the previous quarter. We're going to show how to configure SUPERSCOPES and multicast scopes and why they would be used. We'll talk about using DHCP v6 with Windows 2012 Server and how we can support IPv6 with DHCP. And then talk about high availability options for DHCP, which is, in other words, having clustering and failover and so forth with DHCP, so you don't have a single point of failure. Once we're done, and then we're going to kind of transition into DNS. We'll talk about using DHCP for DNS registration. That way, we can register systems in DNS using DHCP. So there's kind of a connection there between DHCP and DNS. And then we flow into DNS. We'll do a quick overview of DNS structure and components. And then we'll talk about DNS security. And then finally, some of the advanced options available to us with DNS. So let's get started with an overview of DHCP. DHCP is the Dynamic Host Configuration Protocol, or DHCP. It is part of the TCP/IP protocol suite. So it's used to assign IP addresses to hosts automatically from a defined set of addresses. So this is how, when we turn a computer on a new network, we get an IP address automatically. And I think most of us are probably familiar with this concept. So some of the aspects of DHCP: we have DHCP operation, server installation and configuration, scopes, options, DHCP relay agents. We're going to talk about each one of these here in this unit. So basically, the way DHCP works, IP addresses are assigned via DHCP are usually leased. They're not permanently assigned, although there is a way to permanently assign IP addresses. To prevent a disruption in communication, the client attempts to renew the lease when the lease is about 50% expired. So let's say you get a lease for 1 week. On day 3.5, it's going to do a request for a new IP address to renew its lease. And the DHCP is based on broadcast packets, mostly because we don't have an IP address yet. So in order to communicate with the DHCP server, we have to use broadcast packets, and hopefully the DHCP server receives that broadcast and then uses a unicast to communicate with us. So the request for an IP address between a DHCP client and a server is a 4-packet sequence. First, we send a DHCP discover, where the client transmits a broadcast via DHCP or UDP source port 68 to a destination port of 67. And again, this is a broadcast. And then the DHCP offer is where the DHCP server receives the discover packet and responds with an offer. And then the DHCP request, the client responds by requesting the offered address. And then finally, the DHCP server sends an acknowledgement acknowledging that they now have the IP address. So here's just a pictorial of what that communication looks like. So it's a 4-step process: DHCP discover, DHCP offer, then we send a request for the IP address that it offers us, and then it sends an acknowledgement that we can now begin using that IP address. And of course, it's more than just IP addresses. There are also other things that are sent in DHCP as well. So it's the IP address, the default gateway, the DNS servers, sometimes NetBIOS and things like that can also be included. So a client uses unicast packets to renew the lease. So when they do the renewal, they can use unicast because now we have an IP address and we know the IP address of the DHCP server. They gave us that IP address, so we can use unicast for that. So a successful renewal is just a 2-step process. You send the DHCP request because you already have the IP address. You say, I'd like to continue using this, and then it's going to send back an acknowledgement. So it's just the last 2 steps that we saw in the previous slide. So the renewal request could fail. If the server responds but can't honor the renewal, the request address may be deleted or deactivated from the scope. The server might not respond. In that case, the client keeps trying its current address until 87.5% of the lease interval is expired, and then it sends out a broadcast packet again. There's 2 possible results from the DHCP request. You could have a DHCP server responds, or there's no response, and the client starts the process all over again. That is, if there is no request to the broadcast packet, as we discussed before. So here are the DHCP messages. So you have messages 1 through 8. These are the different, and you can see here, you might recognize some of these, like DHCP release when you run the release command, and so forth. So to install DHCP, the DHCP server role is installed in the Add Roles and Features. We looked at this last quarter. You can also install it with a commandlet in PowerShell. And after installing, the DHCP console is available in the Tools menu in the Server Manager, which again you saw in the previous quarter. So the DHCP clients have no way of determining whether a DHCP server is valid. For example, if somebody were to go into your network and start up their own DHCP server, they may respond to those broadcast packets for an IP address. So we don't want to have rogue DHCP servers on our network, so we might require that DHCP servers are authorized. So DHCP authorization requires enterprise administrator credentials. So you can authorize with the PowerShell. You just type add-DHCP server in DC. So a scope is basically a pool of IP addresses and other parameters, as I talked about before, the DHCP server uses to lease an address to the clients. So a scope consists of the following required parameters. So it's going to have a scope name, the starting and ending IP addresses, the prefix length or subnet mask, and then the lease duration, so how long your DHCP client can keep an address. So there are exclusion regions. These are addresses that can be excluded in two ways. You can do de facto exclusion, which is where you set the start and end IP address in the scope so that several addresses in the subnet fall outside the scope's range. So you can maybe have just the first 50 addresses or the last 50 addresses and the rest are outside the range so they won't get assigned. Or you can create an exclusion range, which can consist of one or more addresses in the scope that the DHCP server does not lease to clients. A reservation is an IP address that's associated with the MAC address of a DHCP client, so that whenever that client requests an IP address, it always gets the same one. So the IP address in the reservation must fall within the same subnet and use the same subnet mask as the scope. So you can force a client to release a reserved address and get a different address by typing ipconfig/release and then ipconfig/renew. And I think a lot of us have done that, just in general troubleshooting. Sometimes with Windows you have to do that. So again, a reservation is how you can always make sure that the server or a device always gets the same IP address. In many networks, we do this with servers. So a lot of our servers will have a DHCP reservation. So we don't set the IP address on the server, but rather we allow the server to do a DHCP request and always just receive the same IP address. So it's managed by the DHCP server. There are options that can be assigned at the following levels. There are server options, which affect all the scopes. You also have scope options, which can affect clients that get a lease from the scope, policy options, and then reservation options, which are based on a computer's MAC address. So some common DHCP options. NNN represents a 3-digit number that identifies the option to the DHCP packet. So here are some common options. 003 is the router, 006 is DNS server, 015 is the DNS domain name, then WINS servers, and so forth. So these options allow you to define additional details that are passed to the DHCP client, as I said before. So 003 is essentially the gateway address. 006 would be the DNS addresses. And this is how when you do DHCP, you automatically receive those addresses. You don't have to manually set those. All right, so server options are configured by clicking the IPv6 or IPv4 node in the DHCP console. So you right-click the server options and then click Configure Options. The server dialog has two tabs, the General tab and the Advanced tab. The General tab has a list of available options in the upper pane, and Advanced has the same list of options as well as a list box to choose the vendor class, which is a field in the DHCP packet that's used to identify a device model or an operating system version. Now, a relay client is basically a device that listens for those broadcast messages that we described earlier, and it forwards them to the DHCP server on another subnet. So by default, DHCP can only work in one subnet because broadcasts are only sent on one subnet. If you send a broadcast packet, it does not leave your subnet. So that would mean that you would need a DHCP server on every single subnet. But rather than having an individual DHCP server on every subnet, instead you can have a relay agent on each subnet, which relays them to a centralized DHCP server. So you don't have to have, a separate DHCP server on every single subnet. So you can still manage DHCP addresses from the central server without having to configure the DHCP server with network interfaces on each subnet. Good Lord, if you can imagine, if you had 100 subnets on your network, you'd have to have 100 Ethernet cards on your server, which would get old pretty quick. So it's kind of a nice feature to be able to use these DHCP relay agents. But you still have to install the DHCP relay agent on each one of these networks, which of course could be on a domain controller. So the relay process is basically the client is on the same subnet as the relay agent. It sends that discover broadcast The relay agent then forwards that message to the servers, the DHCP server with a unicast, and it can route that because it's a normal IP device. And then the DHCP server receives the message, and since the reagent's address is in the message, the server knows to draw an address from a scope matching the relay agent's IP address. Then the DHCP server sends a unicast offer to the subnet the message was received from. The relay agent forwards that offer to the broadcast and broadcasts it to the subnet it was received on. And then the DHCP client broadcasts a DHCP request. The relay agent forwards it to the DHCP server. Likewise, it sends the acknowledgement back to the client. And that's basically the entire process. So basically, the DHCP relay agent simply inserts itself in the middle of the communication to facilitate the communication between different subnets. In the next slide deck, I'm going to talk about superscopes and multiscopes.